Video, I'm going to talk about systems of equations. When you're dealing with these types of problems, the best way to approach them is to isolate one variable and then use that value to find the remaining two variables. So let me go ahead and show you. Say we have this system of equations. I can cancel out the x terms from equations 1 and 2 by multiplying this equation by 2. That would give me 4x, and if I added that to equation 1, that would yield 0. Let me show you. I'm going to rewrite equation 1. Now for equation 2, if I multiply it by the number 2, I have 2 times 2x, which is 4x, 2 times negative y, which is negative 2y, 2 times 6z, which is 12z, and then 2 times 17 is 34. If I added these two equations together, the x terms would cancel out because negative 4x plus 4x is 0. 3y plus negative 2y is y. And 7z plus 12z is 19z. 25 plus 34 is 59. So now we have an equation that has only two variables, y and z. Now let's do the same thing that we did here before on another pair of equations so that we can get another equation that has only y and z terms. Let's take equations 1 and 3. But if I multiply this first equation by 2, I'll end up with negative 8x for the x term, and there's a negative 8x term right here. If I subtracted both of them, the negative 8x's would go away. So I'm going to start off by rewriting equation 3. Now for equation 1, I'm going to multiply it by 2, because once again, I want to get a negative 8x here. So 2 times negative 4 is negative 8x. 2 times 3y is positive 6y. 2 times 7z is positive 14z. And 2 times 25 is 50. So like I said earlier, we have two negative 8x terms. If we want to get rid of them, we can subtract these equations from one another, which will get rid of these terms. Now let's work with the rest of the variables. Negative 5y minus positive 6y is negative 5y minus 6y. So that's going to be negative 11y. 3z minus positive 14z is going to be negative 11z. And then negative 5 minus 50 is going to be negative 55. So as you can see here, we have two equations, both of which have only y and z terms. Now we can use those two to isolate one variable. So let's go ahead and do that. So I've rewritten my equations. I'm going to choose to cancel out the y terms because I can see here that if I divide this whole equation by 11, I'll end up with a negative y term right here, which should cancel out with a positive y term up here. This equation 2 divided by 11, well, when we're dividing this equation by a number, we need to divide each term in the equation by that number. So negative 11y divided by 11 is equal to negative y, because the 11's cancel out. Likewise, negative 11z divided by 11 is equal to negative z. And negative 55 divided by 11 is negative 5. Okay, so now we have an equation with a negative y term. Let's rewrite our equation 1 so that we have y plus 19z equals 59 up here. Now hopefully you can see that if we add these two equations, we'll be able to cancel out the y terms. The y plus negative y obviously cancel out. The 19z plus the negative z gives us 18z. And then the 59 plus negative 5 is the same as 59 minus 5, so that's 54. Now, to solve for z, we can just simply divide both sides by 18, and z is equal to 54 divided by 18, which is 3. So z is 3. Now, the great way of using this method to solve system of equations is that now that we found z, we can plug that back into these equations up here to solve for y. Taking this equation here, I had negative y minus z equals negative 5. Now I know z is equal to 3, so let's go ahead and plug that into the equation. Negative y minus 3 is equal to negative 5. Okay, so now we can solve for y. Let's add 3 to both sides so we can separate our variable from the numbers. That should give us negative y equals, these cancel out, and negative 5 plus 3 is negative 2. So negative y is equal to negative 2, so that means y is equal to 2. Okay, so now we have y equals 2 and z equals 3. Now we can plug that back into the original system of equations to find x. So I'm going to go ahead and rewrite equation 1 from the original problem that we had. And now we know that y is equal to 2 and z is equal to 3. So let's go ahead and plug in those values. So we have negative 4x plus 3 times 2, because y is 2, and then 7 times z, which is 3, equals 25. And now we can solve for x by isolating it from the other numbers. Negative 4x plus 3 times 2 is 6, plus 7 times 3 is 21, and that's equal to 25. I'm going to continue solving this equation. I have negative 4x plus 6 plus 21, and so we can basically group these together and get 6 plus 21, which is 27, equals 25. Negative 4x is equal to 25 minus 27, which is negative 2. And if we divide both sides by negative 4, x equals 1/2, because the 2 over 4 simplifies to 1 over 2. So now I have x equals 1/2, y equals 2, and z equals 3. Now to double check, we can plug these values back into the original problem, and if they match up, we know these are right. So let's go ahead and do that. So now that I have my original problem, I can plug in the values and see if they're right. For this first equation, we'll have negative 4 times 1/2 plus 3 times 2 plus 7 times 3 equals 25. Now we know negative 4 times 1/2 is negative 2. 3 times 2 is 6. And 7 times 3 is 21. Negative 2 plus 6 is 4, plus 21 is 25. So we know that that is correct. Now we still need to check for the remaining equations. So for this one, we have 2 times 1/2 minus 2, because y is 2, plus 6 times 3 equals 17. 2 times 1/2, well, half of 2 is 1, minus 2, plus 6 times 3, which is 18. 1 minus 2 is negative 1, plus 18 is 17. So we know that this works out for equation 2. Okay, so now for this last one, we have negative 8 times 1/2 minus 5 times 2 plus 3 times 3 equals negative 5. Well, negative 8 times 1/2, well, half of 8 is 4, so we have a negative 4, minus 5 times 2, 5 times 2 is 10, so minus 10, plus 3 times 3, 3 times 3 is 9. Now we know Negative 4 minus 10 is negative 14, plus 9 is negative 5. So we can see that worked out, which means that x equals 1/2, y equals 2, and z equals 3 is the correct answer to this problem. If you'd like me to go into more detail about systems of equations, or you would like me to cover another topic, please let me know in a comment. Thank you, and please consider subscribing if you found this video helpful.